In this video, we're going to go over how to make complex compound surfaces. So this model here is pretty nice, pretty complex. It has a lot of parts and a lot of relationships between the parts so that they can move. So there's tolerances. So there's a lot that went into it. But for this project, we wanted to have double curved surfaces. And so I see that a lot with the project in this class where you get some really nice objects, but it's just not complex enough. So let's say you're in the same scenario and you just need to add a little more complexity to some of your major surfaces. And so that's what we're going to go over in this video. And so the first thing to figure out is, what is it that you want to do and how difficult is it? So in this case, if I was to do a compound surface, a double curved surface here on the top part of this object, it would take a huge amount of time because a large surface on the top side would imply that all of the fillets would have to be redone, and basically this button would have to be redone. It's a lot of work. So that's the first thing to think about. Look at your object and figure out, okay, I thought I was done with this object, but now I'm told it's not complex enough. So where do I want to add some of this surface complexity? And so I was looking at this object and I think the backside in this case might be the best because you could get some of this compound surface either a surface that is concave or convex, going in or going out. And so I will go over how to basically add some surface complexity, specifically here on the backside of this object, so that this project would meet some of the requirements for the final assignment for this class. So the first thing to understand is what is compound surfacing. So compound surfacing is typically when you have a surface that crashed into another one, and then you have a transitional surface. Now, if you look at this model, it has a bunch of surfaces that you could call transitional surfaces, but really they are fillet surfaces. And so the difference for the term that we use when we call something a fillet compared to a transitional surface is that if you look at the surface as a single surface, so if I explode it, I don't know why it's not letting me explode. Yeah, here it is. And if you look at how it's built, you will see that some of the points of this surface make up they basically tell you how complex that transitional is. And this transitional is made up of 3 points, which tells me that this is actually essentially a cylinder. It's based on the circular, it's based on a circle being extruded. And this is what makes your fillet. The fillet is usually a radii, right? Now, a transitional surface, technically, a fillet is a transitional surface, but when we talk about transitional surfaces, we talk about these small surfaces between two larger major surfaces, and typically they look a little more like this. And if I explode it and I look at the points, let's explode. And let's look at the control points. Yeah, and typically you see something like this, but usually you would see more points. So let me untrim. I will do untrim all, and then I will rebuild. I like to type in all of my commands, but you can always go to the menu and find these different shortcuts. There's a bunch of different ways to access your commands. Since I've been using this software for a long time, I like to type it in. It tends to be quicker. And here you can kind of see the number. So on the left, you have the current number, and on the right, you've got the number you're using to modify. So it's like here you have a degree 2 and a degree 3. So that tells me that this is a fillet because degree 2 for something that is circular like this. Typically, when you see these numbers, they're a standard fillet that Rhino creates for you when you use the fillet command. So usually when you do a transitional surface, you'll see something that's higher than 2. You'll see, 3 is technically a transitional surface as well. Like I said, a fillet surface is a transitional, but for this project, we want to see something that's a little smoother, that has a better transition. So Usually 5 is a good number, so we'll do 5, which automatically changes the upper number, which is a point count. So with 6 vertices, with 6 control points, you'll see that you can have these two sets of points, these two sets of points, and they can be aligned. So if I use the match surface, I can align one of the edge to this one, and I can say curvature. And I could also do this on the other side, but this will prove the point that I'm trying to show you here, that this is no longer a fillet, now this is a transitional. And the difference here is that you have two control points that are aligned to this surface here. And this is still not really compound surfacing, because if I look at the point of this one, oh, actually, technically it is. It's a trimmed surface that intersects with this transitional surface. So this is technically a major surface. It's just flat, so it's not complex enough for for the guideline of this specific assignment. It's not very complex, and we want it to be double curved. We want it to be a compound surface. Yeah, so there's basically 3 requirements for this assignment. One is it has to be double curved. One of your major surfaces must be double curved. And then you also have to have one of these complex transitional surfaces. Now, if you don't have both of them, that's okay, but you're not going to get as good of a grade, right? If you want the best possible grade, you will want to have a complex transitional and a complex major surface. So yeah, I just wanted to go over some of these details, and now we can go over the backside. How do we add some complexity to this backside? So one very quick and simple way that you could add some complexity is you can explode that surface, so it's a single surface. You can have a look at the control points, and in this case, you could simply take some of these control points and you could move them in. So that's what we call a free form. If you use a free form modeling technique, you can add some surface complexity this way. So there's this really handy tool called SEL, so that lets you select things, and you can select an entire row on the U orientation or the V orientation. It's basically the X or the Y of the surface. So I can do cell U, and it will select an entire row of points. And now I can move these points. I can use the move command, or I can use the gumball. Let's click on the gumball, and I can move them in or out. So doing something like this would actually be enough for this assignment. So that's one way to do it. Now, what you shouldn't do, and I've seen a lot of people do this in the past, is go in and use something like a primitive, something like a sphere. And if you use a sphere and you intersect this, you can very quickly get a concave or a convex surface. So I see a lot of people do this. And usually you get some really strange stuff happening once you get to your transitional surface, because transitional surfaces don't usually like primitives like the sphere. And the reason for that is because the sphere is kind of like your radii, your fillet surfaces. They basically have a radii, right? They're a distorted circle. They used to be a circle, and now you scaled your circle to be a different shape. And so this can cause some major issues. So you could do a boolean, you could trim it, but usually you end up with some issues later down the line. So let me go in and cut. We'll cut this. Okay, accept. Then I take this circular surface and I can run the same command again. Trim this. Okay, and then I can join them. So I've seen a lot of people do this, and basically you haven't made a complex surface. You took a primitive and you just added one more primitive to your already pretty simple form, your extruded forms. So that's not really what we want. We want something a little more complex than that. So the freeform technique I showed you before usually works really well. I mean, this does a good job. If that's your design, then that's fine. But if I look at the full object, it's still a simple object. It's primitives and extrusions. So let's look at other ways that we can get something more complex. I will delete this, and actually I can leave it in here for now. And I will look at how we can do other types of surfaces. So one simple method would be, you can go in here and, okay, I don't have the right snaps, so I will use the grid snap. And I will just make a single line. And let's look at the points. Okay, so we have a degree-free curve, and we can take these points and move them up. Let's move this so that it is aligned to the object. And let's just make a simple surface. Now you could revolve it, or you could copy it. Let's copy it here. And let's use the record history. I will use the always record, and I will use the mirror command, mirror one curve to the other side. So now if I look at this, and if I make any kind of edits, you can see the right side is moved with the left side. And if I do the opposite, if I move mirrored curve, it breaks the history. So let's do a loft. And let's see if we can use the history. Okay, so let's see if we can use the history moving the one on the left, not the one on the right, and quickly get some curvature. So you can see here this is a double curved surface. The curvature on one side and the other is not the same, which makes it a pretty complex surface. And yes, the profile curve is the same 3 times. So it's the same at one edge, at the center line, and at the other edge. But we can change that by scaling the object. So we can scale this object here, and we can get some really, really complex curvature. So if I select the center curve, you can see here, you can see what this surface looks like, and it's actually very, very, very complex. So that's one very quick way to add some surface complexity to your object. So let's see how we would take something like this, and we'll use the move command to be a little more precise, and I will remove the grid snap, and I'm just looking at the way that it intersects, and I'm gonna try to get it very close to that fillet surface. That should work, so something like this. And then I will adjust this edge profile, and I will use the scale command. And let's say we want something like this. Okay, so we'll do the opposite. We'll remove curvature so that the center profile is very curved and the edge profiles are less curved. And what that should do is it should allow us to get closer to that edge. Okay, so let's say this is the surface we want to use. Let's see. Okay, so this is joined. We could keep that. We could, yeah, let's keep this one. And then let's keep all of our fillet surfaces. And we will hide everything else. So now we can really focus on this surface and the relationships between this complex double curved surface and the transitional. And so the first thing we want to do is we want to cut this surface in a way that will work well with this upper edge. You can see this upper edge here, it has 4 sides, but also 4 corners. And these are ball corners, but they're also three-sided. We usually want to avoid three-sided surfaces, especially for complex transitional surfaces. So one thing we can do is we can join everything here, and we can use the duplicate edge. I think duplicate edge is under curve, curve from object, and duplicate border or duplicate edge. So if you use duplicate border, it will duplicate only the edge that are naked edges. So this works really well in this case, but there's also duplicate edge, which is dup edge. So that's the shortcut for it. And this one lets you select the edge that you want to convert into a curve. So now I have curves I can use and work from. But so I already did that here. Yeah, I did that here by doing the duplicate border, which created all of the curves I need. Now, one thing you want to be careful about. Yes, I do not want construction history for this one. And actually, I don't want to record the construction history anymore. One thing to be careful about is here you have a full continuous curve. So when you use that curve to create other objects, for example, if I extrude this surface, you'll see that sometimes, actually here it did it, sometimes you don't get individual surfaces like this. Sometimes you see a single curve, a single extrusion with a single edge. So a single starting point and a single end point, like a cylinder. So you don't want that in this case. And so to avoid it, sometimes what you have to do is explode your curve so that it's not a closed curve. And then you use that to cut an object. So that's something you could do. In this case, I think this should work pretty well. So let's see, can we do an offset so that we can remove this triangle surface later on? If I do an offset, yeah, let's try doing an offset and see if it works. 0.3, nope, it's gonna have to be more than that. Maybe 0.5. And 0.5 is too much. So anything between 0.3 and 0.5 should give us good results. So let's do 0.4. And now we get a tiny little fillet here, but the surface is not exactly where we want it. So what I will do in this case is scale it in 2 dimensions. And let's see if we can find a good center point. Is that the center point? Yeah, it is. Okay. So we want to line up here with this center. Doesn't have to be perfect because it's transitional, and so as a transitional we can have one side that's bigger than the other. For a fillet it has to be constant, but for a transitional it does not. So that should work. We have a little fillet or transition here between the straight lines, and yeah, that should work well. Let's try doing an extrusion and see if the extrusion will work or not, and you can see here it will not work. So what happened here is it did exactly what I mentioned before, where you have, so here you have a straight, but here on this side you have like a fillet, which is what we want, and here on this other side you do not. On this other side you do not have this little fillet. So to avoid that, what you sometimes have to do is explode. So very often if you explode this type of curve, it breaks down your curve so that you have nice fillets or nice transitions. And this will be very important if we want a four-sided corner surface, a corner transitional surface. Okay, so it looks like we have all of the curves we need. Oh, that's very strange. It broke it up into small patches. So sometimes you get this where one of your curve is overly complicated Like it doesn't need to be so many edges. So we'll join it, but what you'll see here is it's broken up into small segments, and we don't need that. We can have it be a single curve. And so typically to fix that, you can just join everything. Just be very careful about the corner one. We don't want to join that. Yeah, if we just remove the two corners and then join them so that they're a single curve. I don't want these long curves here to be broken up into small segments. And then once you have that, if you want it to be a single curve as opposed to something like this, where if I extrude it, you'll see it still remains a bunch of small patches. No, it did not. So sometimes when you extrude it, it breaks it up into patches, and sometimes it does not. And typically the reason why it does that is because of the relationships. So if the relationships between your points is tangent, it should be able to create a nice smooth surface. If it's not tangent, if you have something that's not as smooth as it should be, sometimes it breaks it up into multiple patches. So what we want to make sure here is that it's a single surface, not multiple patches. Okay, so that worked. So yeah, we can use that, extrude all of these curves, and we can use that as a construction to make this four-sided surface into this more complex surface that has four sides and also four corner surfaces. So let's do this, select this surface and trim anything that is outside. Okay, it looks like it broke the history, which is completely fine. And we are basically done. So we're done with that major surface. It's a very complex major. And now we can work on our transitional surface. We'll move this up just a little. And that's it. So now we can just delete that. You can see if you've done this correctly, when I show all of the other surfaces, I should get a large surface and then a large gap in between the surfaces. So now if I use something like the blend surface, so if I use this blend surface command, I should be able to get something pretty smooth in between the two. And if I use curvature, it will automatically give me a very complex transitional surface. And that's it. That's pretty much all I was looking for, something like this. So now you have something really complex with a double curved major surface and a complex transitional surface, which is also curvature implied. So it means it's very smooth. You have a smooth transition between this side surface and this complex double curved surface. So that's it. That's what I would recommend to do if you find yourself in this situation and you have to add some more surface complexity for your object. Now, sometimes it gets a little complicated, like here, where your blend surface may not go the right orientation. So it's twisting a little at the corner, which, it's not what we want. And so usually you can fix that very easily by creating some construction lines. Like this one is pretty good. So if your object is symmetrical, you might be able to mirror that to the other side. But if you cannot mirror that surface the way that you need it to, you may have to create some constructions. And typically, if you trimmed your surface correctly, you should be able to find some kind of edge, like this one. You can take this line here, which gives me the orientation, so basically the relationship between this fillet and this surface, and you can scale that line. You can scale it in 3 dimensions. So in 3D scale, using the center point, you can enlarge the curve. So you can see now the curve is a little bigger than it needs to be. And if I go from a top view, I can use the project command. If I project from a top view, project this line, press Enter, select the surface. We'll select this surface, press Enter, and now we get a perfect curve on surface that follows the surface continuity. And so the reason why that's really useful is because now we can align a transitional curve. So it's basically just a curve, right? You can take your line. Let's say we use a degree 5. Let's do a degree 5. And we just set up a line here between the two. If you look at it, you'll see it has 5. It has a total of 5 points, right? 6 points if you count the starting point. So 1, 2, 3, 4, 5, 6. And so what that allows us to do is match. Can we match a curve? Yes, match. So you can use the match command, not to be confused with a match surface. We're matching a curve, not a surface. And you can match this curve to this construction curve we just created. And I clicked on the wrong edge. If you click too far on the right side, it tends to try to align to the opposite side. So let's try that again. Enter, press on this edge, press on the correct edge of your construction curve. And here we can ask it to be curvature implied. Press OK. And do this on this edge as well. Now, sometimes you may have to move some of the points and do it again. Like in this scenario, it looks like you may have to take one of these points here. Sometimes you can move it just by selecting the start point and the next point. So that could give you better results. Sometimes you can just freehand the whole process and just go kind of sideways. And you can pull this point, do the same thing. You're going to see it's all twisted now. It goes sideways, a little to the left, a little to the right. But then you can use the match command one more time using curvature. And it should realign the curve so that it continues with our construction curve. And so this should fix that issue that we just saw before, where the surface just wasn't lining up the way we wanted it to. So if you do that just a couple of times, as long as your object is symmetrical, you should be able to get the results you're looking for. And here it looks like the object is actually not symmetrical, so we can't really use that. But if we use the blend surface, we actually have a good edge here that we can use. So we'll just use the duplicate edge, and I will just reuse the edge that was created by blend surface. Okay, so I created a construction curve that is based off of a blend surface, and then I'm deleting the blend surface so that I can also use this edge. All right, so I have a very dialed in curve for the right side, and for the left side I just used the one that was automatically created by the blend surface. And using these constructions I can do something like a sweep. I can do a sweep too. The rails are typically the longest edges, and then the sweep would be this cross section and this one. Now if I press enter, I can also change my options. So you'll see here sometimes it kind of loses that tangency or that curvature. And if you change your options to tangency, usually you get really good results. And sometimes that really depends on your cross sections, but if you have the correct cross sections, you should be able to use curvature and it should give you really smooth results. So let's use that option, and that's it. So that's how you would create a complex major surface and a complex transitional surface, which gives us this compound surface that we're looking for specifically for this assignment. And that's what I would suggest you do if you don't have enough surface complexity, and for your assignment, if you're asked to create more surface complexity, this is the way to do it. Just add some double curved surfaces to something that's flat, and then redo your transitional surfaces wherever they're needed. Make sure you have a nice four-sided corner surface, and that's it. Yeah. So I hope this makes sense, and if you have any questions, just let me know.